We're recording. Right, let's just go through then. Let's just check that you know exactly what you're doing. Alright, so I think some of you are maybe thinking it's more complicated than it is. Okay? So the volume of a prism, maybe we should, I know Owen added this to his sheet, the volume of a prism, so the volume, remember we said is the cross-sectional area, so I can put A, and I'm going to put a little cross for cross-section, however you want to do it, and then it's multiplied by the length, or the height, or whatever you want, okay? So all we need to do is find the cross-sectional area and then multiply it by its length or its height. And all of these questions, to be honest, you've been given the area. So, for instance, these cylinders, the cross-section is what?
Circle.
It's a circle. So that's the cross-section there. That's also the cross-section. How do I know I've been given the area? Exactly. It says centimetres squared, not centimetres. So I know that if volume is the cross-sectional area times the length, that means the volume is 12 centimetres squared multiplied by 8 centimetres. So my volume is 96 cubic centimetres. Okay? It is as simple as that. So this one would be 15 times 7, which is 105 cubic meters. Okay? These ones, again, they've given you certain values. So we know the cross-section they want us to use is not the shaded one, it's actually the one they've given us the answer for. But it is as simple as, this one is 7 times 9, which is 63 cubic centimetres. This one is 26 times 3, 78 cubic meters. How are you getting on so far?
Good.
Alright? It's quite simple, isn't it? These ones, they're just cylinders, but this time the other way up, just to show you. So the cross-sectional area is still given to you. Okay? So this one is 50 times 5, so that's the cubic meters. This one would be 27 times 10, which is 270 cubic meters. The triangles, again, there's no real difference there. The surface area has been given to you already. The triangles are there. So it's 14 times 10. That's 140 cubic centimetres. This one would be 22 times 13, which is 286 cubic centimetres. Everyone agree?
Yep.
Okay. Rightio. So then, this is the bit that seems to confuse people. Yeah. So,
Isn't that the thing I was wondering?
exactly. This not quite as tricky actually as your homework, because you're not being asked to find the radius of the circle, you're being asked to find the length. But same idea, you follow the process of your homework. So I know that the volume is equal to 19 times whatever the length is. But I know the volume is 418, so I've got 418 equals 19 times L. So L is just 418 divided by the 19. So that is
22.
19. Units. What are the correct units?
Centimeters.
It's just centimetres. Okay, so all of those are the same. So this one would be 16 times L equals.
224.
So we've got 224 divided by 16. So L is 14 centimetres. And so on. We can do all those. They're all the same because it's just the length. Okay, your homework was harder because you had to work out a value in the circle. Right? Right, I'm just going to go to this one. Alright? These are the ones I asked you to do in your book because there's no work. But I just want to go through. This one's easy enough because it's just the area of triangle, which is? Yeah, so we've got so we've got base times height divided by 2 times whatever length it is. So this one would be base is
16.
height is divide that by 2 times it by 50. So I'm not going to do all that, but that's what you know the answer will be. However, I want to know this one. This we have to kind of make an assumption, which is what? What kind of triangle has it got to be? It must be a right angle triangle for us to be able to do it. So then we've got base and height, or base and height, doesn't matter which way around you use it. Okay? Same with this one, we're assuming that this is a right angle triangle. The only way we can do it. But those are easy then. The cuboid's relatively easy. Find the length, same idea. But just want to go through, what would you do with these ones? Right? Go on then, what's your other question for me?
So this one.
What is it? What shape is it?
It's not a cuboid.
It is a cuboid. Yeah. But yeah, which face do we have to use? Good, interesting one. This one. Could we use this one?
Yes.
No, because it's not a constant cross section because this goes up. So the only way that's a constant cross section would be if I went from this front face backwards that way, yeah? So that means that the surface area, the cross-sectional area must be which shape? Must be this one, which is a what? Trapezoid or a trapezium. What was the formula for the area of a trapezium? No, it wasn't, was it? You have a formula, but
A
like
plus B times H divided by 2.
yes. This being one of the sides, this being another. What is that side length? 60. Okay. This is the. So this can be A. This can be B. The height is that one, 80. And then we've got, as a prism, we then multiply by its length, which would be, that would be the length, which would be 80, yeah? So it's a trapezoidal prism. You want to make those notes on your sheet so you know what to do when you get there. That makes sense to everyone? Don't forget you've got this formula book that I gave you a copy so you could have out in lessons and use and make notes on and that kind of thing. So don't forget to use it. Yeah, I'm going to go back up and do the other two. Right, have you made notes? Yeah. Okay, right, so what I was going to ask then is, these two, what would be the cross-sectional area, the base that we need to use?
For the top right, it'd be the T.
Right, so the T shape is the cross-section that we need to use, because that's the thing that is constant all the way through. So we've got to remember, how do we work out the area of that T shape? What must we do? Oh?
Can I suggest something? If we cut the parts, the arms off of the T, it'll be 4 times
Yeah.
3, which is.
Well, I'm not going to insist they do it your method, but what he's saying is it needs to be split into rectangles.
Yeah.
So what he's done is
Yeah,
he's split it up that way to turn it into 3 rectangles.
So
I would have actually not done it like that myself, not that it matters. I would have just cut it into
Yeah, that's what I was
2 rectangles. So I've only got 2 to do. But we've got all the dimensions, haven't we? So for instance, we know that this is 4. This whole length is 10. So I know that one's 40 centimetres squared, that bit. And this little bit is 5 and what?
4.
4. How do I know it's 4? Okay. What? Not yet, because we're about to go. We're in the middle of something. How many? Go on, explain why this is 4.
So since the top of the T is 10,
Yeah.
that means the bottom.
That makes this also 10, yeah.
Then 10 minus
That's 3. That's 3. Makes 6. So it must be 4 in the middle. Yeah. So I can work out the area of the T. Fine. Okay. What's the cross section on this one?
Going through that way, like from through the top here to.
It's not going that way, it's actually going down. The cross section has to be the O shape. And we go down. Because the O shape goes all the way through, or at least we assume it does. So we've got to work out the O shape. How would you do that? Daniel?
Work out the volume for the little bit.
You could do that actually. Work out the volume of the little bit.
Then subtract that from the volume of the outside of it.
Yeah, I could think you could work out volumes of big and small. You could actually just work out the area of the O shape by doing a square, big square, small square. But yeah, the volume works as well. Okay? Alright, make sure you've made the notes before we go. We've got 1 minute.